Evaluate the integral of x e to the x dx using the tabular method. The tabular method is integration by parts in disguise. For this method, we will set up two columns. The left column is for d differentiation, and the second column is for I antiderivative. This means we will need to make a choice of u and v. In this case, since x is an algebraic expression, we'll let u be x, and therefore v is e to the x. We then put these two expressions or these two factors in the first and the second column, respectively, with the first column being u, x, and the second column being v, e to the x. We then successively take derivative or differentiate the left-hand side. The derivative of x is 1, the derivative of 1 is 0, and we can stop when the derivative is 0. There's no need to find the derivative 0, which is still 0. In the second column, we successively find the antiderivative. An antiderivative of e to the x is e to the x. An antiderivative of e to the x is e to the x. And we stop at this step because the left column is 0. We then multiply the first row in the first column with the second row in the second column, and then continue doing this successively. Notice that we stop taking the antiderivative of e to the x in the last step because 0 times anything is still 0. However, for this method to work, we will need to alternate the sign. For the first product, we would need to use the plus sign. For the second product, we would need to use the negative sign. And for the next product, we would have to use the plus sign, and so on. The shortcuts for the integral of x times e to the x using the tabular methods is x times e to the x minus e to the x, and then plus c. Notice that there is no integral sign here because we're using the tabular method. The answer is x times e to the x minus x plus c. If we factor out e to the x, then we have e to the x times x minus 1 plus c as the answer.